Okay, to the second part of exercise 6G, we're going to do two questions. Consider harder questions, and so let's start with this. This is part J of question 1. Start with this, and probably substitution technique is not very useful here, but what we can do is expand this. Check carefully. Square. We expand this. This is, make sure your work is absolutely spot on. And y negative x times y negative x is y negative x times y negative x, and plus I will do this one. I have y of negative x, and then I'm going to do this one, get e to the power negative x, and lastly 1 and 1 I get plus 1. Now by law of indices, we add the two exponents, so e to the power negative 2x plus 2e negative x plus 1. They are the same, so I can write them as 2. It's like 1 apple, 2 apples, so that means we have 2 apples. And so I got this now. And you can then now just integrate them according to the table given. You integrate e ax plus b. You get 1 over a e of ax plus b. This will be plus c, but in this case it would not apply here. So integrating e to the power of negative 2x, that will be negative 1 over 2, because in our case a is actually negative 2, e to the power of negative 2x. This is plus 2, but this is going to be negative 1 because of negative x is the coefficient is negative 1. E to the power of negative x plus x, and put within square brackets 1 and 2. I do a little bit of simplification. It's minus 2e x plus x. I think now we're ready, so let's do this. And so we just substitute the x value with 2. And it's negative 2 plus 2, and minus this one, negative e negative 2, because we're going to be substituting x as with 1, and minus 2e negative 1 plus 1, and there you have it. And so I'm going to do a little bit of simplification before I turn on the calculator. Okay, I can do this, and plus 2 in negative x minus 1. Now I'm going to call my calculator, and I'll put it one side and calculate this part here. Okay, I'm going to clear the screen, and so what we do is we're looking at this e, so it's e to the power of negative 4, right, and minus 2 to e to the power of negative 2 plus 2. I'm gonna start with the first part and continue. So plus we'll continue from here, e to negative 2, and plus 2 e to the power of negative 1 and minus 1. So if I have been careful, I'll get 1.5235, which means is roughly 1.5235, or 3 decimal places, 1.524. That would be the approximation to this. And moving on to another questions. I'll do one more. This is from question 2. Okay. This is quite difficult looking because of the radical present here. But if you think about it, if you check the x squared plus 16, see, if you differentiate this respect to x, okay, you actually get 2x, and the x is a key, there's a pattern, and we then can say with confidence that if we substitute x squared plus 16 by u, we probably get go able to transform the problem something simpler. Right, let's try that. So we do not do any substitution first, I mean with the value so on, but just straight dive into the problem. Let u be x squared plus 16. Do this. It's 2x. Manipulate a bit. I'm going to do something cute here. I'm going to do du equals to dx. I leave the x, but I divide both sides by 2. So you see, and the reason is because I have x dx, I would be able to later do this cute thing here, as you can see. I'll show you. We don't write 30 first. X squared plus 16 dx. I will tell you why later. We perform this transformation first, okay? Because if we do not perform transformation first, we have a problem with the limits. And we just do the transformation first. I do one extra step before I do this, the transformation. And now I am ready to substitute. This is square root of u, and where else this is actually half du, and the half can be written in front. Du, you probably remember that the square root of u is actually u to the power of half, right? So you have half integrating u to the power of half du. That is our problem. And so first we're going to integrate it. So you have u power of half plus 1 half plus 1 right here plus c. Now because this is not a definite integral right now, I know the original problem is definite integral, but this is not definite integral, so you plus c to be safe. Don't want to miss anything, and you have go to plus c, and this is equal to half times 2 over 3, equal to 3 over 2 plus c, and that would be 1/3 of u about 3 over 2 plus c. But remember that what u was actually x squared plus 16, 3 over 2 plus c. Okay, remember this. Now move to this. Right, now we are ready to perform the definite integral. And definite integral is of this function. What this would be then in square brackets 1/3 x squared plus 16 to a power 3 over 2, but now without c, because if it's indefinite, non-definite, you get this, but since it's a definite, c is not necessary anymore. You write 0 and 3 here, and now you're ready to substitute whatever here. 16, right? 3 over 2 minus 1/3, now 0 squared plus 16, 3 over 2. I'm going to call my calculator. Right. Clear the screen, and let's do this, perform this calculation here. So 1/3 of in brackets 3 square plus 16 to the power of 3/2. And that completes the first part of the calculation, and subtract 1/3, and this is actually just 16 because this part is 0. Oh, missed it. Okay, 16 and the power of 3/2. I think we check a bit whether we enter everything correctly. If then we have 61/3, and which is so you have 61/3. There's 20 of 1/3. So I advise that you try the other questions in the other parts in question 2 and also question 1 of this particular exercise. Now, good luck.